So we've seen the idea of having a child process coming out of this fork function. And now in this video, I want to talk a bit about ending or exiting processes because this is something that's important to see when we have multiple processes running. We may want to end one at some point when it's no longer needed. So let's discuss a little bit about that process. So first off, there's two real ways that a process will typically end or exit in an application situation. So the first is going to be if a process receives a signal that has an action of terminating a process, and we would call this an abnormal termination. You can think of this as like if you run a process and the process is hanging and you hit Control C on your keyboard or Control Z, these are signals that would typically cause an application to terminate. So that would be an abnormal termination. The other type of termination is a normal termination, which actually uses a system call, and that system call is going to be underscore exit. It looks something like this. So every process, when it exits normally, runs this underscore exit system call. So it turns out when you actually reach the end of this main function in C, it's going to end up exiting through this exit system call. Now, the way that it actually does this in C is not necessarily directly through this underscore exit system call. There's actually another C function called exit, which is going to provide some additional functionality on top of the underscore exit system call. With the underscore exit system call, what happens is when this process is called, it ends the process immediately. So if a process calls that system call, it ends immediately. With the exit function in C, what happens is it calls some exit handlers, it does some cleanup, things like fleshing out the standard IO buffers, and then it calls the underscore exit system call finally to end the process. So this exit system call here does some cleanup, the underscore exit system call does not. It just ends the process immediately. So that's the main way to think about these two system calls. Now let's talk a little bit about when we might use these different functions and what their outcomes are going to be. So here you see that I have a really simple example where we have a fork. It's got a child process and a parent process. This one prints that it's in the child process. This one prints that it's in the parent process. And then we have a print out here that will print for, both cases. Child or parent will hit this because it's not in the case statement. Now you'll see that when we run this code, right, what we get as a result is we get that outside of fork case prints twice because the child and parent process both hit that point. Now, what if I wanted to terminate the child process before it reaches this? I want the child process to just do this code and then I want it to exit. Well, there's two different ways that I could do that. The first way would be to use the exit function like this. And we provide a status code for it. So this status code is like the exit code of the application. So generally, actually, we'd set this typically to a 0, I believe, to say that this was successful. And then any other code we can set to say, some other status. And it can be any value between 0 and 255. So we could use this exit call here, or we could use underscore exit. Both of these will exit the process. Now the question would be, which one should I use for a child process? And the answer is that you should use underscore exit. The reason why we use underscore exit is because if we use the normal exit function, it's going to end up flushing out like the standard input-output buffers. It's going to call exit handlers. These exit handlers may do things like deleting temporary files, these types of things. Since the exit handlers are shared between the parent and child process, we don't necessarily want those to execute. So to avoid that, we just use the underscore exit system call to terminate the process completely without doing any of those handlers or anything like that. So now when we take a look at this, we'll see that the child process ends before it reaches that final print at the bottom. So this is great. This is exactly what we were looking for. Now, in understanding that, let's discuss a few other things that we could do with exiting. I mentioned the idea of exit handlers. Exit handlers are really just functions that run when a process is exiting or when a process is ending. So we can register these using another function in C, and that function is called atexit. An atexit is generally going to take in some sort of function, or a function pointer rather, and that function is going to execute when the process ends. So for example, I could have this simple void run on exit function, and what I could do is I could have it print out something like process is exiting, like this. And what I could do is I could say at exit, I could provide a pointer to run on exit as a function. Now the run on exit function, when we use at exit, it can't take in any sort of arguments. It can't have any sort of return. It just has to be a void function, no arguments. And generally the main idea of this process is that what it's going to do is it's going to do anything that needs to be done before the application ends. As I mentioned before, things like deleting temporary files might be a common example. Any sort of cleanup we want to do before exit, we could do using this type of function. Now, let me show you what happens when this runs, okay? When I run this, you'll see process is exiting. So you see that that happened, and it happened specifically for the parent process, not the child process. Why? Because the parent process exits with the normal exit system call, but the child process exits with this underscore exit system call. Remember, underscore exit does not call any of the exit handlers. So this function does not execute for the child because we used underscore exit. And hopefully this helps you understand better what the difference between underscore exit and the normal exit is. And I can explicitly do this, right? I could come down here and use exit like this to explicitly exit the parent function, just to make it, very explicit exactly how those are exiting. And you'll see here that we get that result. Now, what's interesting is that if both of the functions were to exit using the underscore exit, so both the parent and child process, we would see that this handler, run on exit, would not execute at all. Okay, let's take a look at that. So we can compile this, and when we run it, do you see that it didn't execute at all? Only the things that weren't associated with that function executed. And that's because when we use underscore exit, it does not call any of our exit handlers. Only if we call exit or if we return from main will those exit handlers be used. So that gives you a bit more intuition. Now, if this were to exit normally, it would call this atexit handler. So I could show you that now when we do this, that exit handler runs twice. Do you see that? So you can understand that if we had things like deleting temporary files, if we were to use a normal exit from the child process, it could cause problems because the file would try to delete twice. That could be potentially, something that could crash your program or cause some problems. So this gives you an idea of how we can run functions on exit. Now, there is a second way to run functions on exit, and that is going to be using the onExit function. Now, the onExit function runs very similarly to atexit. However, it gives us a bit more functionality. That being that it allows you to provide arguments to the function that's running on exit. So for instance, I could say that I want to do run on exit, and I could provide to it some arguments. And those arguments have to be a void pointer. So for instance, if I wanted to provide the value 10, I could put in void star 10 like this. So I just cast it into the type of a void pointer with a value of 10. Now up here, what's going to happen is this will get two arguments actually by default. The first argument is actually the exit status. That's always given to these functions when they run through onExit. And then the second is the arguments that we passed in, which we have a void star args for. Now if I want to print these values, what I could do is I could do something like this. Process is exiting, and I could say status %d arg equals % maybe ld, right? Something like this. I'll put my new line, and then I'll put in my status, and I'll parse those args as a long value. I can pass them as an integer as well. Either or would work. So this is just one example of this, right? So this is going to show both the status of the exit as well as the arguments associated with it. Now remember, this will only happen for this exit, not this exit, because it's an exit handler, so it only runs on the exit, not underscore exit. So we'll see this result clearly here. So you see that the process is exiting, it has a status of 0, and it has an argument of 10 as we set. Now if we change this exit from underscore exit to a regular exit, we could provide maybe a different status for it. And we can actually see that that will show here. Do you see how they both have two different statuses associated with them? So it should help to give you a bit more intuition around the idea of exiting processes. Now, exiting processes is important because later on, we're going to see that we can do things like waiting for a child process to exit, then we can check its status code and information to be able to handle any situations where that child has done something and we want to be able to do something with those results. With this, you have the basic ideas of being able to exit processes through both child and parent processes. So thanks so much for watching, and I'll see you in the next video.